Okay? Remember that Wednesday is another e-learning day for you guys. So we'll probably have to do attendance again, just like we did last time, and you'll have a lesson to do. Okay, that's enough. All right, so let's go through and do all of the substitution problems. So I have indicated next to the problem how I'm supposed to do it. So we'll go ahead and just do all of the substitutions, and then we'll go back and do all of the other ones. Okay, this is so simple. You guys know how to do this. If I have to use substitution, what do I need to do first? Get a variable by itself. So you can pick, it doesn't matter, but I think it would be easiest to get this guy by himself. So I can rewrite that equation as x equals 4 minus 2y, right? Huh? Yeah. And then I will take this and substitute it in right here, because that's what x equals. So 2 times 4 minus 2y minus y equals 3. So I'll do my distributive property here, and now I'm just going to collect my terms and solve my equation. And it looks like y equals 1. Now, am I done? No, because what do I need to do? I have to find x. So I'll take the 1, you can plug it in anywhere. I'm going to plug it in right here, but you can plug it in anywhere. It's a y value. Plug it in anywhere you want, it doesn't matter one bit. If I put 1 in here, x equals 4 minus 2. So x is 2. And the answer to the problem is the ordered pair 2, 1. These are lines. I'm looking where these lines cross. They cross at a point, and that point is 2, 1. Right? Let's do the same thing with this one. It makes no difference, you guys, which variable you get by itself. But this one's already by itself, isn't it? So doesn't it make sense to take this and plug it in here? So I'll have x plus 1 squared equal 5. Now what do I do with this? Be careful. Foil, that's a foil. That's a foil, folks. X plus 1 times x plus 1. So I will foil it out. Then what? That's a mess. Combine my terms, so x squared plus 1, 2, 3 x's. Now what? Get 0. It's a quadratic equation, so we want to get it set equal to 0. So subtract 5. And then what do I do with my quadratic equation?
You can put it in the quadratic.
I could put it in the quadratic formula. This one actually factors pretty easily. You could use the quadratic formula, but since this one factors and that's going to be faster, how does it factor x?
1 x minus 3.
Plus 4 minus 1. They gotta multiply to give you 4, right? So it's either 2 and 2 or 4 and 1. If you really can't do that, then you're gonna need to use the quadratic formula, because you need your answers. You gotta get the answers. So what are my x values?
-4.
-4 or
1.
+1. Now, if there's two x's, -4, +1, then I'm gonna have
2.
two y's, right? So what's the y? And again, plug it in wherever you want. This is an x value. Plug in -4 wherever you want. I'm gonna put it right here. If x is -4, then y would be -3. And if x is 1, then y would be 2. Now, why are there two answers? Well, did you notice that this equation had a square in it? So it is not a line. You don't need to know this, but it's actually a parabola that opens sideways. So when I take that parabola and this line, do you see how they could intersect in two spots? Two lines can't. Two lines are going to intersect in only one spot. But when you start throwing in other shapes, you can get more than one answer. All right, there's one more substitution, number 6. All right, so x minus y equals 4, and 2y minus 2x equals 3. And we're going to substitute. Okay, so if we are substituting, what do we have to have first? A letter by itself, right? A variable by itself. It doesn't matter which one you get by itself. Do whatever flips your switch. I like to go easy with the easiest option. I think the easiest option is adding the y to the other side here. So this is what x equals. I'm going to put it right there. So 2y minus 2 times 4 plus y equals 3. Whatever x equals, plug it in place of x in the other equation. All right, so now I'll do my distributive. Uh-oh. We got trouble in River City here. What happens? So we're left with -8 equals 3. No solution. No solution. We'll put the little empty set there. What's happened in the problem is these are two lines, but they're parallel to each other. And are they ever going to cross then if they're parallel? No. And how do we know it's no solution? We get some kind of nonsense statement. It can't possibly be true. All right, so those were all substitution. Now we're going to go back and do the exact type of problem using elimination, which happens to be my favorite. In case you were interested. Now, if we were substituting, we would get y by itself. Probably, that would be the easiest thing to do. But I'm eliminating. So what do I do with elimination? What is that, Daryl?
You have to get one of the variables to be the same thing so they can cancel out.
Exactly, one positive and one negative,
Yes.
but the same thing. So again, it might be easier to focus right here and multiply this equation by 3, because that will make this a positive 3y. And when I add, just like Daryl said, they're going to cancel. Right? So that leaves me with 17x equal to 85. So x equals 5. And then just like before, we're not done, what do we have to do? Go back, and I can't emphasize enough, guys, no one cares, plug it back in somewhere. Now it's an X value, so make sure you're plugging it in for X. So if I put it in right there, it's gonna say 10 minus 3y equals 13. So subtracting 10, negative 3y equals 3. So y equals negative 1, and my answer is the point 5 comma negative 1. Problem 4 is another elimination, and it's full of squares, but don't let that alarm you. That isn't going to change anything that we do in terms of the process.
Does that mean there's 2 answers?
I don't know how many answers there's gonna be. Could be 2, could be 4, could be 3, could be 1, could be none, who knows? We're gonna work it out and see. So we gotta eliminate, I don't care, what do you wanna do?
Two, so.
What?
Times
If we do the top one, you're gonna have to multiply by negative 2, everybody understands that, right?
two. Better.
Okay, so negative 2x squared plus 6y squared equals 22. You're multiplying all the way across by negative 2. And then adding that, so your x's canceled. We're adding, so we have 7y squared equals 28. So y squared equals 4. And what's y?
Take your square.
So what's y?
2.
Or
Negative 2.
negative 2. Remember when you square root, you gotta do the plus or minus. So it's 2 or negative 2. So my y's are positive 2 and negative 2. Those are my y's. Now how do I find my x's?
You plug it into
Plug them back in somewhere. So I'm gonna plug them in this bottom one. So I have 2x squared plus, I'm plugging in 2. So that would be 4 equals 6. So 2x squared equals 2, x squared equals 1, and x equals
Oh,
plus or minus.
1 negative.
one.
So when I put in positive 2 into my equation, I got 1 or negative 1. Now you can write it that way, or you can write it as separate points. Now, I still have to put in negative 2. What's gonna happen when I put negative 2 into my equation? Wake up. I'm gonna get the same thing.
Yeah, one.
I'm gonna get exactly the same thing, right? So I'm gonna get a 1 or a negative 1 for that one too. So in reality, how many answers did I come up with? 4. You can write them individually, you can write them together, doesn't matter. There's 4 of them, 4 answers. All right, last one. Now be careful, we are eliminating. So what am I gonna have to do before I even begin? I'm going to have to do what? Get things lined up. If I'm gonna eliminate, they have to be lined up. So I'll move this 6y over. So 2x plus 6y equals 16. This has to be over on the other side of the equation if I'm eliminating. If I was doing substitution, I would love having it over there like that, but if I'm eliminating, no, this is the way I need it. All right, what do you wanna do?
Two negative.
top row by -2. Okay, so I'm gonna get -2x minus 6y, -16. Uh-oh. Uh-oh.
We're done. We're done. 0.
What do we have on this side? When we add 0, and over here we have
Going to the origin.
0. Now, that is different than before, when I don't remember what it was, but we got something like 3 equals 8. Okay, that is not true, right? So that means they don't intersect. Is this true? In fact, it's always true. So the answer is they are the same line. If you graphed this equation, you know, get out a piece of graph paper, and you graph that equation, and then you graph this equation, they would be right on top of each other. They are versions of the same line. Okay? Now, that's it for 7-1. That homework will be due Tuesday, but I would hope you would get it done before then. Monday, we're going to have a quiz over substitution and elimination. Here is your practice.
It's full. So same line, would that be the same as all real or not?
No. You can't really say all reals, because remember, we're looking for points,
Oh, yeah.
and all reals is just a set of numbers.
Okay.
So let's say same line. The concept is the same, the idea is the same.
So if I did like -30 to positive, these are wrong.
Yep. Yep. Okay, boys and girls, everybody got a practice quiz? All right, let's take a moment. This is material you know, so take a moment and work through it on your own. And oh, Shinichiri, I need to take attendance, oh Lord. They haven't radioed me yet, but it's coming. All right. So Brett's here, Joshua, Lucy, Leslie, Izzy, Aubrey. Lewis is not here. Ava, Mackenzie, Jared. This is exactly what your quiz will look like. You will do one substitution problem and one elimination problem. Do Does anyone feel comfortable with what you did with number 1? Has anybody finished number 1 yet? Okay, Tegan, would you mind putting it on the board, or would you rather not? It's up to you. Okay, what's on video, that's why I asked. All right, so she's working on that one. You've already got number 2 done? Okay, you want to put it on the board here? I'll use a black marker. You guys keep working, if you're not done, keep going, do them both. Make sure you can. In the real world, if you have to solve a system, you can do it however you want. But for Monday's quiz, I'm gonna force you to do one with substitution and one with elimination, to make sure you know both strategies. Yeah, you have to be able to do it using the right strategy for the quiz on Monday. And how do we write our answers? As an ordered pair. And make sure, no matter what order you found your variables, when you write your answer, it has to be X, comma, Y. Okay, Tegan got 3, 4. I don't know.
That's right.
Is that right? Daryl says it's right, so it's right, okay. Does anybody have a question? She chose to get Y by itself in that top equation, which makes sense to me too. And then she substituted it in, here's Y, she put it right here. Be very careful distributing your negative like she did. Once she got X equals 3, it looks like she put it in right here. And worked it out and got 4. Does anybody have a question about that? Okay. Jared got 1, 2. Did anybody else get that far? 1, 2. Now he used elimination, so it looks like he times the second equation by 2. So he got 6x, 4y, and 14. And then he added and got 7x equals 7, so he got x is 1. Looks like he put it in here. Put 1 in for x. And got 2 for. Please, if you're all bothered by that, do work on your homework. See if you can get those problems, and then come in for office hours if you're confused, because we're not really spending any more time on this now. We're moving on to 7.2, which is equally easy, but brand new. This is old stuff. Okay, so everybody prepared, you know what the expectation is. Monday we have a quiz. 2 problems, 1 substitution, 1 elimination. Gonna write our answers as ordered pairs. Okay. Enough of that. Today, we're going to talk a little bit about matrix algebra. Doing stuff with matrices. Have you guys worked with matrices in math class before? Didn't think so? That's okay. They're easy, you'll enjoy them, but we have to get some vocabulary down. So, let's talk about what a matrix is. I'm going to put an example on here. I'm going to use a different one. Okay, so this is a matrix. This is an example of a matrix. A matrix is a rectangular, see, a rectangle? A rectangular array, that means arrangement, that's a math word for arrangement, of numbers arranged in rows and columns. 100% guarantee a question on your test for chapter 7 will be define matrix. Guarantee it. The whole chapter is about matrices. We are going to know what a matrix is. A rectangular array of numbers arranged in rows and columns. These are rows. Do not be confused. If you go into the gym, aren't these the rows of bleachers? Don't they go this way? Those are the rows of the matrix. Columns are like you have on the White House. Columns go like this. So the rows of the matrix are these. The columns of the matrix are these. When we talk about matrices, we talk about their dimensions. And the dimensions of a matrix are rows by columns. Now, I know that looks like a times sign, but it's not multiply, it's read by. So just if I said, what are the dimensions of this room? You might say 10 by 20. Same thing, rows by columns. So this matrix, matrix A, is a 2 by 4. It has 2 rows and 4 columns. If a matrix has the same number of rows as columns, so in other words, a 3 by 3 or a 5 by 5, then it's called square. A square matrix has the same number of rows as columns. And in matrix land, those are the most special. We love our square matrices.
So you said same number of rows as columns?
Yep. So just like if I had a room that was 8 by 8, I would say it was square. Same idea. Now, rectangular array of numbers. The numbers are called the entries or the elements. Either word is acceptable. Entries or elements. That's what these individual things are called. So this is an entry in this matrix. This is an element of this matrix. The numbers inside the matrix. Okay? Now, if I want to talk about this 3 right here, let's say I want to talk about him, I would identify him like this. First, that's this 3 here. This 3 right here. First, I would use a lowercase a because that number is located in matrix A. So capital letters name the matrix, and then all the things inside the matrix are little a's or little b's or whatever matrix you're in. Any idea what the 1, 3 stands for? I'm looking at that number. The row in the column, exactly. So the 1 tells me which row I'm in, the 3 tells me which column I'm in. So if I wanted to talk about this guy, right here,
25.
he would be A. Which row is he in? 2. Which column is he in? 1. Okay? Now, if this matrix were called B, then that would be a little b. All right. A scalar is just a real number. So, for example, we're going to have numbers outside of our matrices, like it's like a coefficient. It's a coefficient. Think of it as a coefficient. And we're going to talk about how to deal with that. But when we talk about scalar, we're talking about nothing more than a real number. Okay, this is not a matrix number, this is just a regular old number outside the matrix. That's called a scalar. The, you guys in physics, anybody in here in physics? You've talked about scalars, haven't you? Yeah. The language of matrices and vectors is a little bit different. They have some different vocabulary words. And scalar is one of those. And then equal matrices. Can anybody give me your own definition of what you think equal matrices might be? Like if A and B are equal, what do you think that means? Okay,
They're either both the same, like both square, or like maybe one has 2 rows, 3 columns, and one has 3 rows, 2 columns.
okay, so.
Or are they invert or not invert?
So I'm just gonna go with what you said, so they're both square, so like 1, 2, 3, 4, and 7, 8, 9, 10, 1, 2, 5, 7, 3. Would you say those are both square? Would you say they are equal? So modify your answer.
Like, that one's 2 by 2 on the bottom.
Okay, so now they're both 2 by 2. Would you say those are equal?
Maybe.
Well, they have the same dimensions.
I thought, isn't that what the other definition is? Like when it's like 3 by, isn't that
No,
what?
that's the definition for square.
Square, that's what I'm saying,
Yeah.
that's what I keep
Okay,
wanting to say.
so he's comparing these two though. The question is, are they equal to each other?
Yeah,
Are
right,
these equal to
because
each
they're
other?
both 2 by 2.
The first rule for being equal is exactly what Zach said. They have to have the same dimensions. Now, they don't have to be square. They could be like this.
So then it's something about the.
They have to have the same dimensions. If they're gonna equal each other, they have to have the same dimensions. Okay? Now, what else do you think they have to have? Because I'm gonna tell you right now, these two are not equal.
Same numbers.
They have to have the same numbers, all right? Let's talk about that. Do you think those two are equal? They have the same size and they have the same numbers. Do you think they're equal? No. No.
Gotta be in the order?
They gotta be in the same spots, exactly. So the second criteria is they have to have the same corresponding entries. And what that means is what Josh said. They have to have the same numbers in the same spots. If they're gonna be equal, these are not equal. They have to have the same numbers in the same spots. Now you're thinking to yourself, okay, that's sort of stupid, right? We're talking about this. There is a whole branch of mathematics devoted to matrices. Okay? When I was in college, anybody who's a math major takes a semester-long course, what's called linear algebra, and you do nothing but play around with matrices. So all these little fine points are important. We're just skimming the surface. Definition, equal matrices. Same dimensions, same corresponding entries. Same size, same numbers, and same spots. Okay? All right. Now, let's do some problems. Now, we have our basic definitions. We sort of know what's what. So now we're going to do some problems. Okay. So here's matrix A and B and C. Okay. What are the dimensions of matrix A? How big is matrix A? look up at your definitions. Dimensions are rows by columns, 2 by 2. And that's how you write it. 2, it looks like 2 times 2, it's not. It's 2 by 2. How about B? What are the dimensions of B?
2 by 3.
2 by 3. Rows by columns. I always remember that. I'm Roman Catholic, RC, rows, columns. Rows first, columns second. All right, A sub 2, 1. Okay, the little a tells me to look in matrix A. And I'm looking at row 2, column 1. So what is the entry that's A sub 2, 1? 3. Perfect. How about B sub 1, 2? Now I'm looking in matrix B for the entry that is in row 1, column 2. 0. And now I'm looking in matrix C for the entry that is in, whoops.
There's no row.
Oh, Miss Ford got tricky or made a mistake. There isn't one, right? Because there is no 3rd row in matrix C. All right. Now we're going to add A and B together. We can't. There are a lot of things we can't do in matrix land. And one is we can't add them unless they have the same size. Because when I add them, I am going to be adding their corresponding entries. And A and B are not the same size. Not
So you
doable.
can't add A and C?
Can I add A and C?
They're like the same size, but like.
Yep,
it's
that's the
not
rule.
same.
They have to be the same size.
But it's not the.
Period. Same size. Are they the same size?
Yeah.
Done. Add them. You can add them. The rule for addition is they must be the same size. They don't have to be square, but they have to be the same size. So what do you think goes right here when I'm adding A and C?
0.
0. And then will come
3.
3. And then,
7.
and then, done. Matrix addition is so easy. Can't do it unless they're the same size, but if they're the same size, then you just add those corresponding entries. Nothing to it. Now, the next problem talks about a scalar multiplication. I'm taking 2 times matrix A. Any thought on how I might do that?
Multiply
Each number by 2. It's like a giant distributive property. So that would be 2, 4, 6, negative 8. The next one says 2C minus A. So I need to take 2 times C. And subtract A. Okay, one step at a time. What's 2C? Negative 2, 2, 8, 0. Everybody okay? Now I'm going to subtract this one. Now, first of all, can I do that? Yep, because they are the same size. Addition and subtraction have the same rules, got to be the same size. So that's subtractable. Here we go. negative 2 minus 1. Negative 3. 2 minus 2. 8 minus 3. 0 minus negative 4. 4. Easy enough? Brand new, but easy. All right. You do G, and you do G, which is V minus 2X.
How do you do that?
How do you do that? You're shaking your head. You can't do that. Because what's the rule for add and subtract? Gotta be the same size. These are not the same size matrices, so it can't be done. Cannot do it. Cannot do it. Okay. Now the fun's gonna begin. Because now we are going to multiply matrix A, which is 1, 2, 3, negative 4, times matrix F, which is negative 1, 5, 3, 0. Before we do this, we need to talk about what the rules of multiplication are for matrices, matrix multiplication. So step aside, repeat one more time. For add and subtract, they have to be the same size. So I could have a 5 by 3 and a 5 by 3 and add them or subtract them, right? Here is the rule for multiplication. Whatever the dimensions of your first matrix are, so let's say I'm multiplying these two matrices together, and P is a 5 by 8, and Q is an 8 by 2. They are multipliable because the rule for multiplication is these two numbers have to be the same. If you're going to multiply, the columns of first must match the rows of second. Okay? And then, furthermore, the answer will be a 5 by 2. So, if I'm multiplying two matrices, these two dimensions have to be the same. And then these two dimensions give me how big my answer is. So multiplying a 5 by 8 times an 8 by 2 is going to give me a 5 by 2. All right, so how about a 3 by 7 and a 7 by 5? Are they multipliable? Yes, and the product would be 3 by 5. Well, what about a 3 by 7 and another 3 by 7? Are they multipliable? No. These numbers must match. So it doesn't matter, I can add those, these would be addable, but they are not multipliable. Okay? This is way different than what any you've ever done probably. Okay? Alright, so let's look at the two I'm multiplying. What are the dimensions of my first one? 2 by 2. What are the dimensions of my second one? Oh, life is good. Can these be multiplied? Yes. And furthermore, the answer will be another 2 by 2. Right? Okay. Now, pay attention. You'll get this. Might be a little confusing at first. I need to fill this spot. I need to figure out what number goes here. That number is in row 1, column 1, right? So I am going to take row 1 and column 1 and multiply those together. So again, this spot, this is my answer. I'm looking for that number. It's in row 1, column 1. So I take row 1 and column 1, and I'm gonna multiply those together. And how I do it is like this. Write down the numbers, I'll do it red. Write down the numbers in row 1, leave a space between them, write down row 1 and 2. And then next to those, write down their column that it goes with. So first number in the row, second number in the row, there they are. And then first number in the column, second number in the column. I'm pairing up the numbers. Now, multiply each pair and add them together. So the number that goes in this spot is a 5. Now, once you do a few of these, you'll get it. It's a little confusing in the beginning. Let's move over here. What spot is this? I want to figure out what number goes here. What spot is that? That's first row, second column. So now I'll multiply my first row times my second column, because that's what spot that is. Row 1, column 2. So I'm going to write down the numbers in the row, and then next to those, I'll write down the numbers in the column. I multiply each pair and add them up. That's not 7, that's 5. 2 times 0 is 2. Or 2 times 0 is not 2.
0. That's
2
what I
times 0
said.
is 0, yeah. Okay? Now, moving to here. Alright, where am I here? Second row, first column. So second row, first column, looking at the green now. Second row, first column. So 3, -4. And then -1, 3. See what I did? I wrote down my row, 3, -4. And then my column, -1, 3. So what's that one? -15. Hey, can you do the last one on your own? Yeah, you can. What do you multiply? What are we trying to fill right here? What's this? Row 2, column 2. So write down the numbers in row 2, 3, -4, and then column 1, or column 2, column 2. And I got a 15. Did you get a 15? All right, we'll do one more. One more.
Is it always that way? For them to be like 5, -5, okay.
Okay. All right. Now we're going to do the same 2 matrices, but we're going to do them in the other order. So we are going to multiply F times A. So first thing, it's a 2 by 2 and a 2 by 2. That means I can do it. And my answer will be another 2 by 2. Well, we're gonna find out. Here we go. What position is this in the matrix? Row 1, column 1. So I'm gonna multiply row 1 and column 1. So what are the numbers in row 1? Negative 1, 5. Column 1, 3. What do I get?
You would get
14. Totally different number. That I got from Simon. All right, now I'll move over here. Where am I here?
row 2, column
This is row
Row 1,
1,
column 2.
column 2. So row 1 is still negative 1, 5, and column 2 is 2, negative 4. Remember, you multiply each pair and then add them together, and what do we get? Negative 22. Alright? Where am I here? I'm ready for this number right here. This is row 2. Row 2, column 1. So 3, 0, and 1, 3. And then finally, row 2, column 2. So 3, 0 again. And then 2, negative 4. 6. So to Zach's point, when I multiplied A times F and when I multiplied F times A, I got totally different answers. So matrix multiplication is not commutative like regular numbers are. The order is very, very important. Okay?